This video will give you more information on the ANOVA assumption of homogeneity of variance of the errors. There are three primary ANOVA assumptions, and all of them are in relation to error, where error is determined by comparing the expected value to the observed value. And error then is determined by how far is your observed from what is expected. So all three of these primary assumptions for ANOVA really are concerned with the error that is calculated for your observed distribution. So the first one is independence. And here we want to look at, are all of these errors independent of each other? Are they independently distributed? Meaning that the error from one individual point or one group is not causing the error in another individual or another group. The second one is normality. And just like looking at normality of your continuous variables, we're doing the same here, but for the errors and the distribution of errors. So you want your normality to indicate that you have a normal curve of errors. And lastly, we have homogeneity of variance. And homogeneity of variance is really looking at the distribution of errors for each of the populations or each of the groups represented is the same, and that there's not a variation across the groups. So this way, when we look at is any particular treatment or whatever our outcome is and how that outcome is being impacted, how does that variance shift between the groups? Because that shifting of variance is what shifts the means to be able to compare those means and see if there's statistical differences. So it's important for the differences in the groups to not be from the violation of homogeneity of variance, but to actually be from a shift in the variance, thus a shift in the. So the third primary assumption for ANOVA is homogeneity of variance. And this is a really important assumption. And this is, of these three, this is one that you really made to make sure that you are meeting. And the reason is because the distribution of those errors is really signifying what's happening for each one of your groups. And if you have one of your groups that are being compared that have really different variance distributions than the others, then instead of seeing that you're getting a shift in variance due to the treatment or whatever you're applying to your groups, you are seeing a difference between the groups just because their variance is different. So you're basically having to ensure that the distribution of their variance is similar enough that it's not causing differences between groups. So then you can look at the placement of the mean within that variance and truly be able to compare the means across those groups. So the test that's typically used to test homogeneity of variance is the Levene's test. And for most programs, including SPSS, you will automatically get a Levene's test with your ANOVA output as part of your results. And it's important to really look at, do you have this homogeneity of variance? And so for this Levene's test, you want it to not be statistically significant, so then you know that all of those variances across the group are the same. Now, one way to better like better ensure that you're meeting this homogeneity of variance assumption is to have all of your sample sizes across your groups be as equal as possible. And so you do not want to have any more than like a 1.5 to 1 ratio of the sample sizes across your group. The other thing is when you have a larger sample size, both within your groups and for the group as a whole, then you're less likely to have this violation of homogeneity of variance. And so it's really important to understand what your sample size is as a whole, and also the sample sizes within each of your group and how those are balanced. If you have a balanced design, then you are less likely to have a violation of homogeneity of variance, and so you have less effects on the type 1 error, where the type 1 error is that false positive error. And so you want to make sure that you both have an ample sample size for your sample as a whole, but also you have a balanced design where your groups have similar sample sizes. So the Levene's test is very similar to this Welch's t-test, and really you would just change which test you're using for your homogeneity of variance test, depending on how conservative you really want to have those results be. This assumption of homogeneity of variance of your errors is actually one of the most important assumptions to be met for ANOVA, because you really can have serious consequences if you have a violation of the homogeneity of variance assumption. And really what's happening is by violating this assumption, you're changing and unable to have enough power to be confident in your statistical results. And what this looks like, it's like a very big change in your p-value, where if you have all of your groups are equal versus those that are not equal. So having homogeneity of variance versus not having homogeneity of variance, it actually can make a big difference in your p-values. And because of this, it really is a difference between having a statistically significant result and not having a statistically significant result. So making sure that you are meeting this assumption of homogeneity of variance is very important. This assumption of homogeneity of variance is important enough where there's actually tests to be able to see how severe of a violation you have and be able to make some adjustments. So if you use this F max option to look at how severe a violation of homogeneity of variance is, if your F max is greater than 9, then you have a problem. But there are citations and references where if your F max is greater than 3, you have a problem. And so that's really industry specific and topic specific and also sample specific. So you have to make sure that you understand what's happening in those areas in relation to homogeneity of variance and the ANOVA test that you're running. And some of the older tests of homogeneity of variance are still available, so you could use those also to test for homogeneity of variance. And then there's these newer ones, which is like Levene's and Brown-Forsyth, which are the ones that are recommended. If you do have a violation of the homogeneity of variance assumption, there are a couple ways that you can deal with them. You could use a specific F test that will be more stringent in accounting for this violation of homogeneity of variance, or you could try a nonlinear transformation. So there's a number of those that you could use to be able to change the distribution of your errors so that the variance is different within groups. The problem with that is that you will have a really hard time being able to interpret your ANOVA results, especially if you're making these non-linear transformation changes to one group but not others. Now their units for their outcome where you're trying to compare are not comparable. When you're running a one-way ANOVA in SPSS, or really any ANOVA in SPSS, you are able to select a number of these different options for testing the homogeneity of variance.